Physics question of the day. We have a question here that says that a guitar string is 75 centimeters long. The wavelength of its fundamental note is, so basically the question is asking us what is going to be the wavelength of its fundamental note. What we need to understand is that for the fundamental note, the succeeding notes will be harmonics, where we have the fundamental notes being the first harmonic. Then we go to the next frequency, which is a multiple of the fundamental notes. That will be the second harmonics, and then it goes on and on like that. And I'm going to show you what it looks like. Let's say this that I'm holding here represents a guitar string, of course always fixed at both ends. Now when you pluck it like this, so you can see what is happening here. This vibration corresponds to its fundamental note, and this is the way it looks like. It looks like this. So where you have at the tip of my finger here, you have a node, and at this place you have another node. Then you have this kind of behavior. So you can see that we have two successive nodes, and that would be that. Don't forget, we know that between two successive nodes we have half of a wavelength. Half of a wavelength, that is what we have between two successive nodes. Let me quickly illustrate what will happen in the second harmonics, that is the frequency after its fundamental note. That one, we can simulate that by fixing another point in the middle here. I don't have an extra hand, so if you fix another point in the middle here and you pluck it, so you have twice of this, one here, another one in the other end like that. So in that case you have three successive nodes, and between three successive nodes you have a full wavelength. But let me go back to the question. So the question wants us to find the fundamental note. So we have this, between two successive nodes you have half of the wavelength, and the length of the guitar string has been given as 75 centimeters. So for every point in time, the length will still remain the same. If you are the fundamental note, the second harmonics, third harmonics, or anything further, the length will still remain the same. So all you have to do to get the wavelength at any of these points is do what I just explained now. So for the fundamental note, we have half of a wavelength. So equate that half of a wavelength. So lambda over 2 equals 75 centimeters, which is the length of the string. So you solve for lambda, that will be 75 multiplied by 2. And the correct answer will be 150 centimeters.